Welcome back to my YouTube channel, and today we are talking about digital forensics and the this is a practical presentation. If you want to know more about digital forensics, you go and check my previous videos, and also there's also a video we're talking about ethical considerations when doing digital forensics. So today we are going to do disk imaging, where we need to create an image for forensic investigation. So if you ever wondered how digital forensics experts capture a hard drive without changing a single bit, so in the world of investigation you don't get a second chance. So if you accidentally modify a file stamp or overwrite a deleted sector, that evidence is destroyed. So today I'm showing you exactly how we preserve digital evidence step by step, from a blank USB drive to a forensically sound image file ready for autopsy. So first things first, we also need to set up our evidence drive. So I'm going to format the USB drive. I'm going to format it. We need to clean it out. Alright, so it's now clean. The USB drive is now clean. The folder is empty, as you can see. Now I need to make this realistic. I'm going to drop some random files onto this drive. So in my folder, desktop folder, I'm going to cut this. Then I'm going to add into my drive, my USB drive, like this. After this, I'm going to delete something that I want you to see that I can recover after I did the analysis with autopsy, right? So we are going to delete this company bank details and passwords. I'm going to delete this one. Yes, I deleted. So there are four files now in this drive, right? So this drive is now a suspect drive, so it contains evidence we need to protect. But here's the golden rule of forensics. The golden rule of forensics, as I mentioned, never work on the original. If you plug this directly into the Windows machine, the OS will write things like system volume information to it. So this alters the evidence. So to prevent that, I'm putting the right blocker on. So I'm opening this zipped folder and then extract. Then after that I extract, I'm going to open it, then say run. Here there are three options: enable the USB write blocker and disable the USB write blocker. So now I'm going to enter one so that I enable it like this. Then I say yes, right? So the USB write blocker is now on, right? So this ensures our original evidence stays 100% untouched. Now some of you might think we are opening autopsy to create the image, but hold on. The autopsy is an analysis tool, not an imaging tool. So we use autopsy after we have a forensic image to create the image. We use a dedicated tool called the FTK Imager. So we are going to open the FTK Imager now. And this is one of the most trusted tools in the industry for creating forensic investigations and forensic images. So it's free, it's reliable, and it verifies the integrity of your copy with cryptographic hashes. Alright, so let's get to it. So you get to the top menu. menu, this one, and you go on create disk image, right? Now the first prompt asks us to for the evidence source type. So I choosing the physical drive. Why? Because choosing a physical drive captures everything: the boot sector, the partition tables, the unallocated space, and even deleted files that are not visible in the file system, right? So a logical drive only captures the active partition, and we would miss all the hidden deleted data. We don't want that. On the next screen, after we press next, right? We see all the physical drives connected to our system, and I will choose this one, the external one. This is our drive, and it's clearly marked by its size. It's 8 gigabytes. Make sure you select the right one, or you might accidentally image your main hard drive, right? So I will click on it, then we press finish. Now we are at the image destination screen, right? This is where we tell FTK Imager where to save the image and what format to use. So I will click add to proceed, right? When I click next to proceed, there are 4 image type options, and I want to break them down. There's the raw DD, which is the simplest format. It creates a bit for bit exact copy. The problem is if the drive is 8 gigabytes, the image is 8 gigabytes. It takes up massive space and it doesn't store any metadata like the case number or examiner name. So the smart is an older proprietary format that is not widely used anymore. So we are skipping it. Then we move on to AFF. This one is the advanced forensic format. Is an open source format that is great for compression and metadata. However, it is less universally compatible than the E01. Finally, we have the E01, the in-case evidence file. This is the industry gold standard. It compresses the data to save space. You can split the image into smaller segments for easy storage, and most importantly, it stores case metadata and calculates a built-in hash for integrity verification. So this is exactly what we want. So I'm selecting A01 and clicking next. Next up, we need to fill in the case metadata. This is critical for legal admissibility. So on the case number, I'm going to put this is our first case of 2026. Let's assume this is our first case for 2026 for the case number. Then our USB 01001 for the evidence number. Then a unique description like 8 gigabytes. Let me say 8 gigabytes containing documents. Right. Then my name is an examiner. Right. Then some notes. This is optional. I'm going to write image. I'm going to write image through right blocker. Right blocker, like this. For the notes section, now we want to choose where to save this image, right? So I'm going to choose folder on my desktop that's written digital forensics. This is where I want to save my image. So image file, I'm going to write suspect USB image, right, like this. So I also choose the fragment size. I usually stick with the no splitting, right, depending on the storage medium. Now I click finish. Then I click at the start button at the bottom of the window. So the image process begins, right? Watch as FTK Imager reads the drive sector by sector, right? So wait as the image is being created, but this can take a lot of time, maybe more than 10 minutes or more than 5 minutes. I'm not sure, but we are going to be patient as we wait for a FTK Imager. And now look at the pen on the screen. FTK Imager is verifying the MD5 and the SHA-1 hashes in real time. So at this point, the FTK Imager is verifying and is verifying the MD5 and SHA-1 that is going to provide after the process is done, right? So when this is complete, these hash values will be stored with the image. If we ever need to prove that the image hasn't been tampered with, we can recalculate the hash and compare it to this value, right? If the image is forensically sound, and there we have it. You need to be patient a bit. Now the process is done, the verification process is done, and you can see on my screen that there is an MD5 hash and SHA-1 hash, right? You can also check the image summary. You can see that there is a case information there, case number. You can see, you remember it, the evidence number, you remember it, the unique description, the examiner, the notes. You can go on and check the information, the MD5 here, checksum, and the SHA-1 checksum that can use to check the integrity of the imaged file, right? Then we are done, and we close. Now the imaging is complete. We have a E01 image in our folder, our destination folder that was on our desktop, right? On our desktop in the digital forensics. So here we find our E01 image file sitting safely on our storage folder. So the original USB drive remains untouched thanks to the right blocker. To recap with what we have done, we formatted the USB drive, we added evidence, we deleted one, we protected it with a right blocker, and we used the FTK Imager to create a compressed verified E01 image. Now we can safely open Autopsy. We load this image file and start analyzing the files, the deleted data and metadata without ever touching the original evidence again. So this is the foundation of every good digital forensics investigations. So if you enjoyed this deep dive into the accusation phase of digital forensics, remember we have a lot of phases when we are doing digital forensics, and we discussed them in our previous video, so we can go and check there. So make sure to like, subscribe, and hit that bell so you don't miss the next video where we actually load this into Autopsy for analysis. I'll see you in the next one.